Everything was in chaos.
I'd never seen anything that destructive that close up.
In 1964, Alaska was shaken by the largest U.S. earthquake ever recorded, magnitude 9.2. In 1964, scientists did not understand how or why it occurred. Immediately, 3 U.S. Geological Survey scientists were sent to figure it out. There were no faults at the surface to explain it. Even with months of careful observation and fieldwork, the cause of the quake remained a mystery. Until one of the scientists, geologist George Plafker, considered the quake in terms of the newly forming theory of plate tectonics. His realization changed our understanding of these great earthquakes.
The oceanic crust is being pushed underneath that part of southern Alaska at a very low angle, and there was slip on the interface between the oceanic crust and the overlying continental crust.
These two crusts are converging at the dramatic rate of 1.5 inches each year. Periodic slip between the crusts produces great quakes, which Plafker called megathrust earthquakes. Scientists now recognize the distinctive patterns of uplift and downdrop at the Earth's surface, characteristic of these quakes.
One of the obvious things that everybody wants to know when you have an earthquake like this is how frequently do they occur? Could you have one tomorrow, or is it thousands of years?
By drilling 50 feet into the Earth and taking core samples, Plafker and his team discovered 9 megathrust earthquakes had occurred in south-central Alaska over the past 5,500 years. The average time span between these quakes is 630 years. The 1964 Great Alaska Earthquake was accompanied by massive tsunamis. Within minutes, one created a wave 20 stories high in parts of Alaska. Some traveled across the Pacific, wreaking havoc in coastal Oregon, California, and Hawaii. The widespread damage and loss of life from this earthquake led to a determination to use science to save lives in the future.
South Central Alaska here is the infrastructure center of the state, and it's also by far the largest population center of the state. And the work that we do, it involves basically the fundamental characterizing of the earthquake hazard, knowing which faults are active, which faults can produce earthquakes, understanding how often those earthquakes occur. And another part is understanding the local tsunami hazard.
Legacies from the 1964 Great Alaska Earthquake and Tsunami include the USGS Earthquake Hazards Program, NOAA's round-the-clock tsunami warning centers, the Advanced National Seismic System, resulting in seismic hazard maps and improved building codes. Altogether, these programs can help predict strong ground motions from future earthquakes and minimize risks. For one example, scientists learned that Valdez was so unstable and at such risk for earthquakes that the town was moved. The 1964 Great Alaska Earthquake changed our understanding of quakes and tsunamis and had a profound and lasting impact on how scientific knowledge can be used to help.